Welcome back. Today we are starting Chapter 3, Acoustic Emission Testing, commonly called AE testing. Now this is one of the most interesting NDT methods because unlike ultrasonic testing or radiography, here we are not sending energy into the component. Instead, we are listening to the structure itself. And that is the biggest difference. Whenever a crack grows, whenever plastic deformation happens, or whenever a stressed material suddenly releases energy, it produces elastic stress waves. Those waves are called acoustic emissions. Now, in real industry, AE is heavily used in pressure vessels, storage tanks, offshore structures, and even aerospace applications. Why? Because AE is excellent for monitoring active damage while the component is under stress. And from an ASNT Level 2 and Level 3 exam perspective, this chapter is very important. Especially topics like a Kaiser effect, a Liddy effect, Javer form interpretation, Chaplai in the Hellthing, Jeter level of the Champling. From loading techniques, many inspectors confuse AE with ultrasonic testing. But remember this clearly. UT looks for defects. AE listens for active defect growth. Very important difference. So in this chapter, I want you to understand not only the definitions, but the actual industrial logic behind the method. All right, let's start. Let's quickly understand what we are going to cover in this chapter. Now, AE is not a small topic. This method combines material science, stress analysis, signal interpretation, and practical inspection engineering. So first, we'll understand the basic principle of acoustic emission testing and how it differs from conventional NDT methods. Then we move into the advantages and limitations. And honestly, the limitations are extremely important because many Level 3 exam questions are based on what AE cannot do. After that, we'll study the actual sources of acoustic emission: crack growth, plastic deformation, stress, strain, and material behavior under loading. Then comes one of the most important sections, the Kaiser effect and Felicity effect. Very important for ASNT exams. After that, we move into the practical AE process: setup, loading, and evaluation. Then we'll discuss waveform analysis, things like hits, counts, amplitude, rise time, and duration. And finally, we'll study source classification and how engineers decide whether a source is inactive, active, or critically active. So overall, this chapter is highly practical and very important for anyone working in refinery shutdowns, pressure vessel inspection, or structural integrity monitoring. Sensors. Let's first understand the basic idea behind acoustic emission. Think about this. When you break a dry stick, you hear a cracking sound. When metal suddenly fractures under stress, energy is released. Even earthquakes work on the same principle. Stress builds up, then suddenly releases. That release creates elastic waves. And acoustic emission testing simply detects those waves inside engineering materials. So in AE testing, we are basically listening to the behavior of the structure while it is under stress. That is why AE is considered a real-time monitoring method. It doesn't just show that a defect exists, it tells you that the defect is active, and that is a huge advantage in industry. Now this slide gives the formal definition of acoustic emission testing. AE is a passive NDT method that detects elastic stress waves generated by sudden energy release inside a material. Now let me explain the important word here: passive. This is one of the favorite Level 2 and Level 3 exam questions. Methods like UT, current, all inject energy into the component. But AE does not inject anything. The structure itself becomes the signal source. The sensor only listens. Very important difference. And because AE detects active energy release, it becomes extremely useful for rack growth monitoring, detection, proof testing, fatigue monitoring, and structural health monitoring. But now, this is what I would look for physically interested. It turns for me for 50 years ago. Proof testing. Information here. Means know as a desire will feature self again. For this, maybe a few physical method believe that's really funded. The story of getting an official emission of great problem, but now, once it mentioned is a man before them in the prost, it madely didn't anything. And in fact, maybe agreed full trinited for me with material. The story of notification that have been great in emission method. Now, this is what I would look for 6 months for physically into the material. And because AE does not inject energy release. And because AE doesn't look at fist everyone it matches. Now, because of them and made not. Now let's begin to the death without of a truth method state. First dividable. And the sensor method provide me. This is explored that the structure of the current method, because AE does not inject energy release, but will not inject energy release. Definitely remove that the methods will discussed for me investigator. The story structural health monitoring. But remember one important limitation. AE can locate active damage, but it cannot accurately size the defect. For sizing, we still need supplemental methods like UT or RT. Very important Level 3 concept. Acoustic emission. When bones crack, that's acoustic emission. Even earthquakes are basically massive acoustic emissions caused by stress release inside the earth. Now in industry, exactly the same principle applies. When cracks grow inside a pressure vessel, when corrosion becomes active inside a storage tank, or when leakage occurs in piping, stress waves are generated. AE sensors detect those waves. And this is why AE became so valuable in industries like fineries, petrochemical plants, aerospace, shore structures, and pipeline systems. One major advantage is that AE can monitor very large structures continuously while they are under stress. That makes it extremely useful for real-time integrity assessment. Important exam section. Advantages and limitations. And trust me, many inspectors only study advantages and ignore limitations. That is a mistake. Because Level 3 exams focus heavily on limitations and practical application. AE has some major industrial advantages. For example, whole ton damage detection. Monitoring simulations completely restricted. Many inspectors focused with a blug, monitoring during operation, and detection of inaccessible defects. But at the same time, AE also has important limitations. For example, the stress. Noise can sensors require direct contact, and AE cannot accurately size discontinuities. So as inspectors, we must understand both the strengths and weaknesses of the method. One of the biggest advantages of acoustic emission testing is large area coverage. Unlike ultrasonic testing, where inspectors scan inch by inch, AE can monitor an entire structure using multiple sensors. That is a huge advantage for large pressure vessels and storage tanks. Another major benefit is real-time monitoring. AE can detect damage while it is happening. Very few NDT methods can do that. AE is also useful for detecting defects in inaccessible areas where conventional inspection becomes difficult. And another important capability is source characterization. Sometimes AE can help differentiate between rack growth, continually convented any forms for given company, erosion activity. That makes the method extremely powerful for structural integrity monitoring. Now let's talk about the limitations, because this is where many people misunderstand AE. First limitation: no stress means no emission. If the structure is not loaded, you may not detect anything. Second, AE is extremely sensitive to noise, and in real refinery environments, noise is a serious challenge. Things like elding machines, iterabation, fluveling, significance place, flegity, flesh, as well as not completely. Gen-related, Cower lines. Another limitation is direct sensor contact. AE sensors must be coupled properly to the surface. But the most important limitation is this: AE can detect and locate active damage, but it cannot precisely size the defect. And this is why supplemental NDT methods like UT are required afterward. Very important exam point. All right, now let's understand where acoustic emissions actually come from. Acoustic emission is generated whenever energy is suddenly released inside a material. Now, in industry, the most important sources are rack growth. Are the primary sources inspectors are usually concerned about. But AE can also come from secondary sources like ion activity, phase transformation. Now remember this important point. The released energy travels through the material as elastic stress waves, and those waves move outward like a spherical wavefront until they are detected by piezoelectric sensors mounted on the surface. This is why sensor placement becomes extremely important in AE testing. Let's discuss the sources of acoustic emission. Acoustic emission is the generation of transient elastic waves caused by the rapid release of energy from a localized source within a material. The primary sources include mechanical deformation, crack growth, dislocation movement, and plastic deformation. These are directly related to material stress and damage. The secondary sources include phase transformation, corrosion processes, friction between surfaces, and magnetic domain activity. When energy is released, it travels through the material as a spherical wavefront. Highly sensitive piezoelectric sensors detect these waves and convert them into electrical signals for analysis. For exams, remember that crack growth and plastic deformation are among the most important acoustic emission sources because they indicate active material damage. Stress is basically force applied per unit area, and strain is the deformation produced because of that stress. Now, when stress remains below the yield strength, the material undergoes elastic deformation, meaning once the load is removed, the material returns back to its original shape, like a spring. But when stress exceeds the yield point, plastic deformation occurs. Now the material permanently changes shape, and this plastic deformation process itself can generate acoustic emissions. This is a very important concept in AE because many emissions are generated during dislocation movement and permanent structural change inside the material. Now we come to one of the most important topics in acoustic emission testing: the Kaiser effect. And trust me, this is a favorite Level 3 exam topic. The Kaiser effect says, once a material has been loaded and unloaded, no new acoustic emissions will occur during reloading until the previous maximum stress level is exceeded. In simple words, the material remembers its previous stress history. Now, this is extremely important in pressure vessel proof testing. For example, if a vessel operated earlier at a certain pressure and during reloading no emissions appear below that previous maximum stress, that usually indicates no new active damage. But once the previous maximum stress is exceeded, new emissions may start again, and that can indicate fresh damage activity. This is exactly why hydrostatic testing is often performed above normal operating pressure. Now, the Felicity effect is basically the breakdown of the Kaiser effect. This usually happens in positive materials, amaged structures, combinage structures, degraded materials. Here, acoustic emissions restart before reaching the previous maximum. Acoustic materials may be deteriorating. Now, the Felicity ratio is calculated using this formula. Felicity ratio equals load at AE reappearance / previous maximum load. A Felicity ratio below 1.0 indicates degradation or damage, and the lower the ratio, the poorer the material condition. Very important concept for composite pressure vessel inspection. Let's break down the workflow in more detail. Step 1 is setup. This includes renser placement, threshold adjustment, amplification settings, and step 2 is loading. Now, depending on the application, loading may be hydrostatic, mechanical, or actual in-service loading. Then comes step 3, evaluation. This is where the Level 3 professional analyzes and source classification, and finally decides whether supplemental NDT is required. Let's break down the workflow in more detail. Step 1 is setup. This includes sensor placement, threshold adjustment, threshold assessment. Step 2 is loading. Now, depending on the application, loading may be hydrostatic, mechanical, or actual in-service loading. Then comes step. Then comes step loading. Step 3 is loading and step, which was made truly as the moment. Step 2 is loading. First of all, is loading general aspected the messenger. Step 2 is loading. Now, depending on the application, step 2 is loading. Step 2 is loading. Then comes step is loading. Step 2 is loading. Now, depending on the application, step 2 is loading. Step 2 is loading. Step 2 is loading, or actual in-service loading. Then comes step is loading. Step 2 is loading. Now, depending on the application, step 2 is loading. Step 2 is loading. Now, depending on the application, step 2 is loading. Step 2 is loading. Then comes step 3, evaluation. This is where the Level 3 professional analyzes density, aviform behavior, and source classification, and finally decides whether supplemental NDT is required. Now, in AE testing, good setup is extremely important. Poor setup means poor data. First, sensor selection depends on the expected frequency range and inspection objective. Then, sensor placement must be optimized for accurate source detection and triangulation. Threshold settings are also very important. If the threshold is too low, you collect excessive noise. If it is too high, you may miss real acoustic emissions. And finally, environmental conditions must always be considered. Things like vibration, ANE, retardia equipment, temperature, for all affect AE results. AE systems commonly use two major sensor types, resonant sensors and broadband sensors. If it's meetingly looking at resonance, are first available for the first page. The resonant sensors a specific frequency range. They are commonly used in weld inspection and pressure vessel applications. Broadband sensors respond across a wider frequency range and are preferred for research and complex signal environments. Now let's talk about one of the biggest real-world problems in AE: noise. In actual refinery or plant environments, noise is everywhere. Things like welding machines, over lines, prefitly displays. Unfortunately, probably put at two levels in investments. In the mid-freet, noise been says to slipped in the mid-video. It's not about a noise related for me. This is a truth of the mid-freet. Unfortunately, responded more problems for many of themself. Now let's talk about one of the biggest real-world problems in actual refinery. Introduction: the noise is a very much love. In actual refinery, noise is not based it more. In the mid-videos of answers they're flitted. The noise is not be approved. In the mid-video is much love. In visiting it would be a great love like them with more frequency. The great contributed in the plant. Now let's talk about one of the biggest real-world problems in AE. Mechanical vibration can all interfere with AE signals. And this is why proper filtering and noise mitigation are critical. Remember, without stress, there is no acoustic emission. So loading is a very important part of AE testing. One common method is hydrostatic or pneumatic loading, used for pressure vessels and storage tanks. Mechanical loading uses weights, jacks, or external forces to simulate service conditions. Thermal loading creates stress using temperature variation. And in-service monitoring evaluates the structure under actual operating conditions. Now here's an important exam point. Hydrostatic proof testing is often performed above normal operating pressure to overcome the Kaiser effect and stimulate new emissions if damage exists. Now we come to the evaluation stage. This is where the AE Level 3 professional interprets the inspection results. Detected sources are classified based on level, intensity, critically active and critically intense sources, which clearly find at the end of states. Critically active and critically intense sources, which clearly find at the ground. With a different sources named it, the type since themselves developed and delivered for. Critically active and critically intense sources. This is where the evaluation stage with critically active and critically intense sources. This is where the evaluation stage with critically active and critically intense sources. Critically active and critically intense sources. The brief is a bit of them to critically intense sources. It's critically intense sources, the completely available from you. Critically active improvements critically intense sources. The brief is a bit of them to critically intense sources. When we care familiar, it's level and critically available. This were the AE Level 3 provided by interpreter sources. This is where the AE Level 3 provided by interpreter sources. Critically active and critically intense sources are considered serious and usually require immediate supplemental NDT. Parameters like extents, existed, and addition time. The stage requires strong technical judgment and experience. Signal analysis is one of the core areas of acoustic emission testing. Every AE waveform contains measurable parameters that help us understand the behavior of the source. These include its, cantidors, amplitude. Analyzing these parameters, inspectors can evaluate republic intensity, repub defect activity. This is where AE becomes both an engineering science and an interpretation skill. Let's quickly understand the major waveform parameters. A hit is one complete acoustic emission event. Counts are the number of times the signal crosses the threshold during that hit. Generally, higher counts indicate higher signal intensity. Amplitude represents the peak signal strength. Rise time is the time between the first threshold crossing and the signal peak. Duration is the total time the signal remains above threshold. And decay describes how the signal reduces after reaching maximum amplitude. These parameters are essential for proper source characterization. In AE testing, sources are classified based on activity and intensity. Activity refers to how frequently emissions occur. Intensity refers to the severity or strength of those emissions. Now, a growing crack usually produces immense event clustering, increasing intensity, actividad. That is considered serious. Corrosion activity often produces more scattered and lower intensity signals. And this is how AE helps engineers prioritize inspection and maintenance decisions. All right, let's quickly revise the important concepts from this chapter. AE is a passive NDT method that listens to stress waves generated by active damage mechanisms. The Kaiser effect and Felicity effect are critical concepts for stress history evaluation. The AE inspection process includes loading, evaluation. Signal interpretation depends heavily on waveform parameters like ITS, COS, generals, Shijugat number of the 15-fort concept in reviews, amplitude, and finally, AE can locate active defects, but supplemental NDT is required for accurate sizing and characterization. Now we move into the exam preparation section. These questions are designed in ASNT Level 2 and Level 3 style. My recommendation? Pause the video. Try answering the questions yourself first. Then compare your answer with the explanation. That is one of the best ways to improve technical understanding and exam confidence. Question 1 tests your understanding of the AE energy source. Remember, AE is passive. The energy comes from the structure itself. Question 2 checks your understanding of plastic deformation. And question 3 focuses on loading techniques. Mechanical loading uses weights, jacks, or suspended loads to simulate actual service conditions. These are classic exam-style questions. For Level 3 preparation, focus especially on loading methods, answer selection, and AVForm parameters, and source classification. These are among the most commonly tested areas in acoustic emission certification exams. And remember, understanding the industrial application is just as important as memorizing definitions. These additional questions focus on ITS versus counts, procedure development, and electromagnetic interference. Remember, a hit is the full signal event, while counts are the threshold crossings within that signal. And AE procedures are usually developed jointly by Cural engineers, Level 3 AE professionals. This rapid review section is excellent for final revision. AE is a passive method. AE alone cannot precisely size discontinuities. The Kaiser effect applies mainly to metallic materials, and resonance sensors are used for specific frequency ranges. These are all important concepts you must remember for certification exams. All right, everyone. That completes Chapter 3, Acoustic Emission Testing. In this chapter, we covered AE principles and limitations, Felicity effects, loading methods, ECLOS analysis, and source classification. I strongly recommend revising the waveform parameters and stress-related concepts once again before moving to the next chapter. Thank you for watching, and I'll see you in the next training module.